So, sorry for the abrupt stop. It was at 21 minutes, as you probably noticed. So we'll have a short piece. When you want to solve with the determinants, it actually takes, to solve for x, you have to do one determinant divided by another. And to solve for y, you have to do one determinant divided by another. And I moved that over too far, so I'm going to move that back. Because I'm going to need more space to my right. Okay, there we go. Before I show you how to put the numbers in there, I'm going to write that out for you in symbols, how you know where to put the numbers into the determinants. The numbers come from the numbers in the original systems. Now, before you can do this, you do have to have them both in standard form. Your x's have to line up, your y's have to be lined up, the numbers it's equal to have to be lined up. It has to be all lined up nice and pretty, or this won't work right. What you do to work this is you put in the bottom determinants, you just put the coefficients off the x's and the y's. So like I'm going to put, from the x's, I'm going to put the 2 and the 3 in, the -5 and the 4. That's what goes in the bottom of both of them. So as far as in symbols, you're taking the first x coefficient, the first y coefficient, then the second. That's always the same. Doesn't matter what variable you're solving for. Okay. The top determinants are what changes based on the variable you're solving for. If you want to solve for x, you put the numbers the equation is equal to in the x column. So I'm going to actually put the -22 and the 13 are going to go in the x column because I want to solve for x. What do you suppose I put in the y column? Do I put the 2 and 3? If this is the y column, put the y's in it. You only change the one column you're solving for. So the -5 and the 4, they stay in their same column. You'll notice these determinants, the top and the bottom, have one column that's identical. The -5, 4 is in both. So you only change the column of the variable you're solving for. Everything else stays identical. So then what am I going to put in the y when I want to solve for y here? Where do the -22 and the 13 go? Yeah, if I'm solving for y, the second column is the y column, so I put the -22 and the 13 into that column because that's the variable I'm solving for. And what goes in x then? The same 2 and 3 you had down below. This will actually be easier when we do it with 3 columns next class, because you'll have 3 columns on there and you will only change one of them to the numbers that it's equal to. You'll leave all the other columns alone. So you change the column of the variable you're solving for. Then you just do the little cross multiply thing and you have the answer. You don't ever have to work the problem with variables. Some people like this method best because they don't have to do the algebra part. And there is a slight shortcut here, but okay, when I start this one, where am I starting? -22 times 4 is -88, and then I do what? I subtract, and I multiply the other two numbers. So 13 times -5 is -65, which really becomes a plus, and so -88 plus 65 is actually -23, I believe. Okay, bottom. What are you going to get? 2 times 4 is 8. And I'm going to subtract. You can't tell I'm trying to make a big deal of that. and then a negative 15, and so 8 plus 15 would actually be positive 23. And what's negative 23 divided by positive 23? That is a negative 1. And there's my answer for x. X is negative 1. Okay, now, you can shortcut on the second one. Which part of this is going to be the same? Bottom is the same, so therefore, what do we know the bottom already is? Bottom's already 23, so I just put 23 on the bottom. You don't need to rework it. Okay, so this one starting in the top left corner, it's 26, subtract a negative 66, and you will be wowed and amazed at what number we're about to get. It's the 92 again, divided by 23, which is 4. And there's that same answer we got before, negative 1, 4, every single time. So it's interesting, you always end up with the same values as you work in the problem. You end up with 92 over 23 every time we solve by whatever method. So, I don't know, I always find this method a little bit fascinating, that it works like that. It's a little crazy. It's kind of weird. What's the part you're going to mess up if you mess this up? Either the subtract or getting the numbers in the right spots. Takes a little practice getting the numbers in the right spots. But if you do a couple of them, not a big deal. So enjoy. You now know Cramer's rule.